We have an array of equipment here, binoculars, telescopes, projectors, all sorts of equipment. Everybody was really convinced they could see it, and now they're all really keenly waiting for second contact, which is the one they really want to get hold of.
So, the transit was underway for the first time in over 122 years. This was only the sixth one ever to be seen by human eyes, and the previous five all have amazing stories associated with them. The first person in history to see a transit of Venus was a young man called Jeremiah Horrocks in 1639. He wasn't an established scientist, just an amateur astronomer with a keen eye for detail. He saw the second of a pair, so the world had to wait for another 120-odd years for another. The next pair were in the 1760s, and astronomers of the time set sail for the four corners of the Earth to take measurements, hoping to pin down the distance to the Sun. But a curious optical effect called the black drop meant the measurements weren't completely successful. The only other transits were seen by Victorians, and for the first time scientists were able to use photography to record them. Today, transits can be seen using amazing new technology, including telescopes in space. We're just coming up to second contact, when Venus is just inside the disk of the Sun. And we have to watch out for the dreaded black drop effect. Now, this is Andy Norton from the Open University. Andy, what is the black drop effect?
Well, it's been seen each time in the past that people have looked at the transit of Venus, but nobody really knows what causes it. What it looks like is when Venus is just onto the Sun and just moving off, as though part of the disk of Venus sort of extends out to the edge of the Sun, a sort of bridge from the dark silhouette.
So it was stretched, you mean?
Yeah, and nobody really knows what causes it. It could be something to do with the Earth's atmosphere. It could be just the very high contrast between the dark silhouette of Venus and the bright disk of the Sun. But what it does do is make it very difficult to judge when that second or third contact occurs.
And they want to time it to the second.
Exactly, and that's why it's really difficult.
Can you see it?
I think we can see it now. I think Venus is just coming inside the Sun, and there's a sort of bridge linking the dark silhouette of Venus to the edge of the Sun. I think that's what we're seeing now.
So it's as though Venus is stretched out?
Yeah. This has been seen, you know, every time Venus has been in transit before, people have reported seeing this, but nobody really knows what causes it. It could be something to do with the Earth's atmosphere. It could be just the high contrast between the dark silhouette of Venus and the bright disk of the Sun. And you can see here, look, you can see it stretching out.
It's stretching, isn't it?
So it's very, very difficult to tell when that actual contact is occurring, when it's actually inside the Sun, because it's kind of stretching out to the edge of the Sun's disk.
So if we're looking for the moment when there's brightness right round, it's not quite yet, is it?
It's not quite, well, could be about now. Could be about now, I think.
I'd give it a little bit longer. How very difficult.
It's very, very difficult to see, isn't it?
Yes.
Yeah, but there it is, Venus on the face of the Sun.
And they want to time it to the second.
That's about right, yeah.
Now, I would say now.
It comes and goes, doesn't it?
Yes.
You can see the sort of bright edge around Venus. Yeah, I'd say it's definitely fully on the Sun's disk now.
All right, second contact.
Yeah. That's great.
That's very tricky.
Yeah. But there it is. Venus,
it really is.
Fully on the Sun.
Hey, it's a transit of Venus. It is quite exciting.
It really is.
Are you excited about it?
I am. I mean, just the thought that no one has seen this since 1882, it's just amazing, isn't it?
It's clearly impossible to time that to the second. I mean, you know, you could not.
I think the only way to do it is probably to say when it's definitely not all on the Sun and when it definitely is, and then take a sort of halfway point between them.
In fact, statistics may be the only way of getting at it.
They may. If we get enough people to measure this, then hopefully the people that measure the time a bit early will be cancelled out by the people that measure the time a bit late, and we'll get a good average between them.
At least there's a chance of that, isn't there?
Yeah.
Wow, that is exciting seeing that, I have to say. Now, Andy, what are we looking at here?
Well, we've got a projection of the Sun here. We're using this little telescope to project an image of the Sun onto this piece of paper here. Now, the image is upside down compared to those we've seen before. That's just because of the way this telescope works, the optics of the telescope.
It's a wonderful image,
It's nice and sharp and very clear,
very
isn't it?
clear.
Yeah.
And I love the cardboard boxes to keep out the extraneous sunlight.
It's all you need, yeah.
Now, let's have a look and see what it looks like in hydrogen alpha.
Okay.
We've got it there, and it looks to me as if there is no black drop. It looks
that's very, well, that's unexpected.
We may have avoided that problem.
We may, yeah, that's interesting.
Captain Cook, you should have used hydrogen alpha.
If only they had those filters.
That's terrific. So we should have a really good time then for both for second contact.
Let's hope so.
And with luck, third contact.
That's to come, yeah, fingers crossed.
One person who's been waiting all his life to see a transit is the elder statesman of astronomy on TV, Patrick Moore. he observed from his garden in Sussex, in between filming for Sky at Night.
Well, here at my observatory in Sussex, the weather is absolutely perfect. A clear sky, we have a marvellous view, and we've seen amazing things already. I've got distinguished people with me, including Dr. Brian May. Brian, how are your observations going?
Fantastically well, actually, with the simplest of equipment, getting a nice projected image here, and we've been following the whole thing very successfully.
Well, of course, you can see it with the naked eye, but you must have an official filter. Be very, very careful. But, of course, the famous black drop being on view. Chris, we saw it, didn't we?
That's right, we saw it projecting just using Patrick's telescope here. But what's interesting, some of the more modern equipment around us with high-resolution cameras didn't see a black drop effect. So our suggestion from around here, as Venus moves onto the sun, that black drop that follows it onto the surface seems to be something to do with modern optics rather than anything to do with Venus's atmosphere or the sun's atmosphere.
I wonder whether they see it when Venus leaves the sun just after midday.
We're here in Much Hall today because it's from this very house behind me that the transit of Venus was first observed in 1639. Now, you might be wondering why no one had seen one before. Well, the answer is that the transit of Venus is impossible to see with the naked eye. The sun is too bright and the black dot of Venus too small. So it took until the discovery of the telescope for it to be observed, and even then you had to know just when to look. Surprisingly, the person who first predicted and observed the transit wasn't an established scientist at all, but a young amateur astronomer called Jeremiah Horrocks.
Jeremiah Horrocks made his discovery in 1639, a time of great turmoil just before the start of the Civil War. He was only 20 years old and a self-taught astronomer, but he'd managed to get hold of a rare piece of cutting-edge technology, a telescope invented a few years earlier. He very soon hit a problem. His observations didn't match the existing astronomical tables, the ones produced by two giants of astronomy, Johannes Kepler and Nicolaus Copernicus. When his astronomer friend William Crabtree reported the same errors, he decided to recalculate the astronomical tables. A bit like a young student today rewriting one of Stephen Hawking's books. Horrocks lived in a small village near Preston called Much Hall, where he was employed as a tutor to the children of Carr House. It was while working on the tables in the autumn of the year 1639 that he spotted an astonishing conjunction. He realised that if he was right, a transit of Venus would happen on November the 24th, in about a month's time. He wrote urgently to his brother in Liverpool and to his fellow amateur astronomer, William Crabtree, in Manchester.
This has not occurred for many years and will not occur again this century. I therefore beg you to watch carefully with your telescope and make whatever observation you can, especially as to the diameter of Venus.
Of Sunday, November the 24th, dawned with the wintry sun hidden behind clouds. Nevertheless, Jeremiah set up his telescope to project an image onto a carefully drawn chart. If the sun ever came out. He couldn't calculate accurately enough to predict exactly when the transit would start. In his later account, he wrote,
I watched carefully on the 24th from sunrise to 9 o'clock, then from a little before 10 until noon, and at 1 in the afternoon, being called away at intervals for business of the highest importance.
Jeremiah's business of the highest importance was attending church. He He was a religious man and probably had a formal role in services. Dedicated Christian though he was, it must have been frustrating for Jeremiah to be inside as the sun came and went behind the clouds.
Today's lesson is from Hebrews chapter 10. We are not...
He knew he might be missing his only chance to view the transit.
For ye have need of patience, that after ye have done the will of God, ye might receive the promise.
It was almost as if the sun was teasing him. Popping out from behind the clouds when he wasn't at his telescope, then disappearing again as he got home. By mid-afternoon, with less than an hour to sunset, he still hadn't seen Venus. Finally, at about 3:15, the sky cleared.
I beheld a most agreeable spectacle, a spot of unusual magnitude and of a perfectly circular shape, which had already fully entered on the sun's disk. Not doubting that this was really the shadow of a planet, I immediately applied myself to observe it.
The telescope projected a reversed image, but before the sun finally set half an hour later, Jeremiah Horrocks managed to make 3 distinct observations of times and positions. His fellow observers didn't do quite as well. William Crabtree was so overcome with emotion that he failed to make a single measurement. And his brother in Liverpool didn't even see it. It was cloudy all day. But Jeremiah's measurements were sufficient for him to correct the astronomical tables and calculate the relative distances of the Earth and Venus to the Sun. Amazingly, the figure he came up with is almost exactly what is given in modern planetary tables. Jeremiah Horrocks' story doesn't end happily. He died a year later at the age of just 21. His name isn't well known outside astronomy, but there's a monument to him in Westminster Abbey, and churchgoers in Much Hool have a constant reminder of his great achievement in the stained glass window above the altar.
Well, legend has it that this is the very bedroom where Jeremiah Horrocks made that historic observation. And joining me now is Professor Alan Chapman, who's the world expert on Horrocks. Alan, why is he such a great hero to you?
Jeremiah Horrocks was the first figure to bring the European astronomical revolution to Britain. And frankly, I've known Jeremiah Horrocks since I was a schoolboy. I'm a native Lancastrian myself, and the story of this 20-year-old who made this formidable discovery I've known as long as I can remember. But why he's so significant is that the great revolution in astronomy that happened in the 17th century was made in Italy, in Germany, in France, in these countries, where, of course, they were coming to prove that the Earth moved around the sun. Jeremiah Horrocks, in his recognition that Venus would transit the sun on the 24th of November, 1639, was the first person to realize that you could make a discovery that went beyond what these great continental giants had done. On Horrocks and his friend Crabtree in Salford, 30 miles away, become the first great, what you would call, creators of the new astronomy in Britain.
But why was it that Horrocks and Crabtree kept this information about the transit to themselves?
Oh, no, they didn't. They wanted to broadcast it across the world. The only problem was the realisation it was going to happen took place less than a month before it was due. And the Postal Service being what it was in those days, Jeremiah, of course, told Crabtree, he told his brother in Liverpool, and he told Samuel Forster in London. But only only one of them had decent weather, and that was Crabtree. And as a result of that, only Crabtree and Horrocks saw the transit.
Well, it's fantastic that so many people can see the transit observations today. Meantime, Adam, it's back to you in Greenwich.
Thank you.
Wow, it's hot when you get this close to the sun. Jeremiah Horrocks was so charged up about the transit because he realised you could use it to measure the distance to the sun. And once you knew that, you could work out all sorts of other stuff, like distances to the planets and even to the stars. Now here is a bit of the solar system. This is Venus poised to make a transit, and here's Andy, who's going to drive Venus because he's an astronomer and knows what he's doing. Well, I hope so anyway. And over here is the Earth. In Horrocks' time, they knew the proportions of the solar system because you can work them out from how long each planet takes to go round the sun. So they already knew that Venus was 1/3 of the way to the sun, but they didn't know how many miles that was. It could have been 10 million, 20 million, or 100 million miles. In theory, there was a simple way to measure the distance to the sun. You send observers to two places on Earth a long way apart. Here they are. We've sent one to the North Pole and one to Africa. Then they make a triangle. So here's one observer, the other observer, and I'm the sun. They make a triangle like that. And if you know these angles here and you know this distance, then you can work out the distance to the sun. But the problem was that the real sun is so far away that the distance between these two angles was too small to measure. They couldn't use this triangulation method for the distance to the sun or even to the much closer Venus. But the transit of Venus changed all that. A cunning astronomer called Edmund Halley realised that using the transit, he could get all the information he needed without having to measure the impossible angles. The method depends on the fact that the transit looks different from different places on Earth. Now, our observers are at the North Pole and in Africa, and we put a video camera in each place so you can see what they see. Now, Andy, could you winch Venus into the middle of the face of the sun, as seen on our screen? There we are. Stop. Stop. Now, this is the view from Pole Cam up here on the top. Now, if we could switch to Africa Cam, look at that, it's jumped up. And if we could see them both together, you see they're quite different. Pole Cam shows Venus down at the bottom of the sun, and Africa Cam shows it almost in the middle. Now, we've adjusted the solar system just a little